Hello and welcome to the video on average value. Okay, so first off, we're going to start with what is an average. So let's define what an average is. That is basically the sum of all values of something. So sum of all values, and then divided by the number of values. Number of numbers, basically, or number of values that you're adding up. Okay? So if we apply this to our the area formula to get an average value of our function, let's say we're starting with a right endpoint approximation. Okay, so this is equal to delta x times f of x sub 1 plus f of x sub 2, and etc., 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 until we get to f of x sub n, right? So that's for the right-hand approximation there, and then this, let's rewrite that as what we know is the length of the interval, so b minus a divided by n, the number of subintervals. So we can rewrite this guy as r sub n is equal to b minus a over n, and then f of x sub 1 plus, and then the rest inside parentheses here. Okay, so I'll continue this on the next slide. So where we're at is the r sub n is equal to b minus a over n, but this time I'm going to kind of rearrange it a little bit. So f of x sub 1 plus f of x sub 2 plus dot 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 plus f of x sub n, okay? And then I'm going to put this thing over n, okay? Because that's the same thing, right? I just moved the n from one side to the other, just around on the right side, okay? And then as you'll see here, this thing is actually, on top we have the sum of values, the sum of function values, right? And then we're dividing it by n, the number of values that we see here, okay? So this thing that I just boxed, this is going to be our average value here, okay? So if we were to rearrange things, we're going to divide by b minus a on both sides, so we get that average value by itself on the right side. What we're going to get is r sub n over b minus a is equal to this f of x sub 1 plus f of x sub 2 plus dot 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 all the way up to f of x sub n, okay, and then all over n, okay? So we see here how on the right side now we basically just have average value of our function, okay, on the interval from a to b, and then on the left side we have 1 over b minus a times our right-hand approximation there, okay? So let's write this bottom line on the next slide, and I'll explain what this signifies. So we have that average value here is now equal to 1 over b minus a times r sub n. So this is our average value of f of x on the interval a to b, okay? And furthermore, this approximation here, this guy, as the limit of it, so limit of r sub n as n approaches infinity, this thing is equal to a limit which is equal to the definite integral as n approaches this infinity there. So by definite integral, I just mean our integral a to b of f of x dx. Okay, so the way to rewrite this, so if we're going to replace r sub n with this, then we're going to get that our average value of our f of x on the interval a to b is basically going to be 1 over b minus a times the integral from a to b of our f of x dx, okay? And that's basically the all-important formula that we need to remember for this section here for average value, all right? So pictorially, what does this mean? So we have, I'll just abbreviate, so average value is equal to 1 over b minus a times the integral from a to b of f of x dx. So let's say we have some kind of graph, okay? So let's say it looks like here's our x, there's our y, then we're going along, so like that, okay? So here's a, there's b, a and b, and I'm going to cut the interval right here, right? So here's our area underneath, but now we want to find on this interval what is our average value of the function. So here's our f of x, right? That's our curve, and average value is actually going to be something, it's going to be about the average height on our interval, okay? So it'll probably be somewhere around here, all right? So average value is this thing here, so I'll put AV for average value, okay? So basically, we can rearrange it a little bit and say that our average value, so if we multiply again by our b minus a on both sides, we get b minus a, and then b minus a, okay, and then so we'll get b minus a times our average value is then equal to the integral from a to b of f of x dx, and this, as we know, is the area under the curve from a to b, under f of x, that is. So area is also equal to average value times b minus a. So what that means is that our average value is here, right? So this is like our height, okay? And then our base is b minus a. That's the full length of our interval, b minus a. So then we actually have some kind of rectangle going on here, right? So this is our height, and this is our base of our rectangle, and this is the area that we found. Okay, so the area under the curve. So that's another way to express it using the average value or the mean value. Okay, so let's try a problem involving average value. So we're going to calculate the average value, I'll abbreviate average value of f of x is equal to x cubed over, I'll say over the interval 0 to 4. Okay? Alright, so let's identify a couple things. So this is our f of x. This is a is 0, and b is 4. Alright? So let's set it up. So our formula for average value is 1 over b minus a, and then times the integral from a to b of our f of x dx. Alright? So if we plug in b, a, and f of x, what we're going to get is a 1 over 4 minus 0 times the integral from 0 to 4 of x to the third dx. Okay, so let's continue here. We get a 1 over 4, and then we have, when we integrate, we get x to the fourth, and then a 1 over 4 again, and then this is being evaluated from 0 to 4. Okay, so then we have that average value is equal to a 1 over 16, essentially, and then x to the fourth, and then our 0 to 4. Okay, so when we plug in a 4, we get 1 over 16 times 4 to the fourth, minus 1 over 16 times 0 to the fourth. So this term goes away, that goes to 0. And this one here becomes basically something like 4 to the second power, right? Which is a 16. So our average value is ultimately going to be a 16 for this function over the given interval. Alright, so the last concept here that I want to introduce is called the mean value theorem. Mean value theorem. For integrals in this case, because we've learned the one for differentiation, right? So for integrals on this case. All right, so for integrals, what it's going to say is that if our f of x, if our function is continuous, because we always want continuity, continuous on the closed interval a, b, then there exists let's see here, exists a value c that is within somewhere in AB, okay, such that the following is true, the following statement. So we're going to say that f of c is equal to 1 over b minus a times the integral from a to b of f of x dx. Okay, so what does this mean? It's basically saying that, so on the right side we see our average value, right? This is our average value. It's going to say that on some interval, let's say, I'm going to draw a picture here because I always like pictures to illustrate things. So let's say we're somewhere here, okay? And here's A and here's B, A and B, okay? And let's say we actually take this, so this is our f of x curve, right? So on this interval, let's say we obtain our average value to be at this height, okay? That's about halfway in between, right? So this is our average value. What the mean value theorem says is that there exists some c, some x value, such that the function evaluated at that point is equal to our average value, which we do see would occur right here on my graph, for instance. So our c would be in there. All right? So that's, again, just to reiterate, our function f of x takes on the value of the average or the mean, hence mean value theorem, for some x equals c inside of our interval. Okay? So that's basically it. And that wraps up, or concludes, our concepts video on average value. I hope that helps, and good luck on your homework.